Well, ladies and gentlemen, I think I only want to do 2 more of these because I'm getting bored with it. Too much of the same thing is not good. So I want to do 2 more and then spend some time on difficult examples using the short truth table procedure, because they can be real difficult and involved. I'm assuming that there are only 10 arguments here in this exercise. 3 of them are in the back of the book. We'll have done about 5 or 6 of them. I'm sure we could leave it to you to be sure you can translate every argument in this exercise for the test. 1 or 2 of them is on the test. Okay? Don't forget about the ones in the back of the book. Then we'll spend some time on the difficult examples using the short procedure of for proving validity and invalidity, because the ones on the test are hard and involved. They are. They require making some assumptions. They require the use of those slashes. Okay, so I think it's probably more important to get those out of there, or get our skills down with those. So let's see, number 5 is in the back of the book. Six is kind of long. I think that you should do it on your own and maybe help your neighbor out at this point. Let's see, I've taken the liberty of choosing words and their first letters, right, to indicate our translation of simple statements. So let's have a look at those. Equality of opportunity is to be achieved. I'm using A for that. Those people previously disadvantaged should now be given special opportunities. I'm going with S. My choice. The key will be on the test. Here's S again. Those people previously disadvantaged should now be given special opportunities. That's another S. Some people received preferential treatment. That's a new one. I'm going with P. Again, there's the same simple statement. Some people receive preferential treatment. Here's the negation of A. See, here's A. Here's its negation. Here's the negation of A again. I think you can handle that. Do it horizontally for a long truth table proof, and then we'll do it vertically for the short. I think we should stop to make sure we all agree on the translation, because we'll just be spinning our wheels if we got the wrong translation. So let's knock that out. You think I did that right? Does it look right to you? This looks invalid to me. Let's find out for sure. No more than 8 rows on the test. In fact, I think they're all 8 rows. I'm not going to say that. No more than 8 rows for the long truth table on the test. It's pointless. Initial guide columns, done. Look right? Okay, let's complete each premise before moving on to the next and finally the conclusion. First one's no problem. We're just using the definition of our horseshoe. It's only false when antecedent is true and consequent is false. So you should have that. Same thing for the second premise. It's only false when antecedent is true and consequent is false. Like that. Put it right. Now in the third premise, you have two symbols remaining. After the simple statements P and A, which is the next most complex symbol? The curl. I'm not asking which is the most complex. I'm saying after the simple statements P and A, which is the next most complex. So it's the curl. Its truth value is a function of A. Like so. Truth value of that horseshoe is a function of antecedent P and consequent curl. The A is no longer in play. Forget about it. Got two falses there. Does that seem right to you? Then the conclusion. Good? Looks to me like we have to check the first four rows. First row's okay. Second row's okay. Third row's okay. Fourth row's okay. I stopped as soon as I came to a false from left to right on the premises. Is that what you have? So what do we read this? Valid or invalid? Valid. Let's whip out a short proof. Make sure you put that false under the curl, for example. Conclusion is the curl. There's only one place to start. Good? Now, what can you tell me about, oh, I forgot this, look. Forgot. See, that's not good. Kata. So I see two truth values I can determine at this time. It doesn't matter which one. What can you tell me about P here? No, I don't think so. Key's truth value matters. Trying to preserve a true horseshoe whose consequence is known to be false.
It has to be false.
Then, what can you tell me about S here? By the same reasoning, right? So I just completed truth values for every symbol in that first premise by transferring a truth value from this S to that S. You see what I mean if you don't stop to check? Well, yeah, but is that good? Is that a true horseshoe in this case?
No.
No, it's not. Please. When you complete the assignment of truth values for every symbol in either a premise or the conclusion, and especially when it's done to some degree by transferring truth values, you must stop and make sure that they all make sense. That is, they add up either to the initial assumption or some other minor assumption we have made along the way, which we do when they get real long. Okay, one or two more, and then we'll move on to the more interesting stuff. 7. Again, this is my choice of what word to key in on and use its first letter for the translation of the simple statement. I'm going to go with demands for terrorist demands are met. Going with R for rewarded. Lawlessness will be rewarded. Terrorist demands are not met. It's going to be a curl D. Innocent hostages will be murdered. I'm going with M. Lawlessness will be rewarded. That's another occurrence of R. Innocent hostages will be murdered. That's M. Fairly simple translation.
Can you back up the edge of it?
Can I do what?
It's just cutting off the edge.
Yeah.
So we can,
More?
move the curves.
So we will have done tonight 1, 2, 3, 4 of them. 3 of them are in the back of the book, so they are essentially done. At 7 out of 10, I'll leave the remaining 3 for you. Working on guide columns. You have a translation? We didn't check that, did we? That's what I have. Is that what you have? Nothing difficult there. These are pretty simple arguments. Got our initial guide columns in place. Go ahead and finish it off. Tell me what you find. Second premise, 2 symbols remaining. Which must be done first? Curl and the horseshoe remain. What has to be done first? Curl. And the horseshoe's truth values are functions of the curl and the antecedent at M. When's the only time a wedge is false?
And it's true and false.
No.
Like what? Like false and
This
false.
one. This one.
Boom. Oh, look, we only have to check row 4 and row 8. Stop already. I'm looking for true premises. I reckon it's valid. So let's check our short procedure. I have a feeling this is going to finish up pretty quickly because that conclusion is going to give us everything we need to know. Notice how we can at this time supply truth value for D here. Then I think we're going to find our, let's see, we're going to find a contradiction here. Yeah, here, we would find a contradiction here. Somebody else may decide, well, I'm going to make this curl false and D true to justify this. Then that person would find a contradiction up here, right? This is probably the easier route.
Could you just look at it and say that it's
Go ahead.
impossible for D and not E to be have the same equation and then just put an X on it?
So that's why we didn't find an invalidating row in the long truth table, because there is none, as proven by the short procedure. So what do you think? You got that short the long method down? We need to look at some more complicated examples of the short, which I think we did last week. We found an exercise bank here. That's some pretty good stuff.
Were those the ones we were doing on the board?
Yeah, but I can't remember where it is.
Page 389, maybe?
Page what?
389?
Was it?
194?
Yeah, well, you can go to any of those. On 394, the author is telling us that they're all valid. On, that's okay. On 389, we've got a mixture on 389.
We just select 322.
Two.
I believe that was today.
We did do something from 320. Well, anybody notices we've done this, or any of these, let me know. Yeah, this looks familiar.
Yeah, we did this one. Sorry.
I think I would have skipped this because it's in the back of the book. But since the author doesn't tell you how to do these, even if you look in the back of the book, it wouldn't look like any of our work. I'm going to have to continue this in the next column like we've done a couple of times. This is number 10 on 389. Because you might want to make sure that I'm even copying these correctly on the board. Hey, this might be difficult. Normally, when the first assignment sort of leads to a lot of others pretty quickly. I don't know if that's going to happen here, but there will be a way to figure it out. I hope. There's an E. Transferring that truth value, right? We know that. There's an E. I'm going to transfer that truth value. Now, I know the truth values of, let's see, one symbol. I'll give you a tip. There's one symbol whose truth value we know, and it's not a letter. Find it.
The conjunction.
conjunction.
Where?
We
What
know
premise?
it's the second,
Right here?
yeah.
What do you know about that dot?
It must be true. Oh, it must be false, because we already have the E false, sorry.
If either conjunct is false, certainly if both of them are. If at least one conjunct is false, the dot is known to be false. What can you tell me about D in that same conjunction? Does not matter what D's truth value is. Do not transfer that slash to that D. We don't transfer slashes. It could be a big mistake. But now I know what B's truth value is. Or must be, if we're going to justify that true horseshoe. What must B be in this case? False? And why do you say that? Explain.
Oh, because horseshoe can only be false if the antecedent is true and the consequent is false.
Yeah, when the consequent is false, the horseshoe could only be true if the consequent is false, the horseshoe could only be true if the antecedent is false as well, right? Yeah. To make B true would falsify this horseshoe. We're trying to preserve the assumption of its truth. Do we have any other B's? Well, there's a B there. There's a B there. Oops. Any other B's? Not that I see. Well, let's see. I know the truth value of one symbol, and it's not a letter. You must find it.
Conjunct of the first one would be in C. For the same reason as in the second one.
The dot here is known to be false, correct?
Which means it's the same reason the A at the beginning has to be.
Well-
Well, C doesn't matter, so then you slash. And
Let's
then
not
the
get
A
ahead of
has to be
ourselves.
false.
C doesn't matter. And what can you tell us about A here now?
It has to be false for that to stay true, for the horseshoe to stay true. You could move that.
So it is playing out pretty nicely. No other C's, but we couldn't transfer the slash anyway. There's an A. There's an A. That's good. That's good news. Uh-oh, I think we're going to have to do our little truth table here eventually. Let's see. I know the truth values of, at this time, not that they won't reveal more, 1, 2 symbols. I spy with my little eye. You must find something.
The tribar in the third one has to be true.
No. That's ahead of the game. Don't know that at this time.
Horseshoe in the third one? Oh, you're right, sorry.
This horseshoe, what do you know about it?
It's true.
It is true. Anytime the antecedent is false, the horseshoe is true, regardless of the consequent. Anytime the consequent is true, the horseshoe is true, regardless of the truth value of the antecedent. Let's see, can we transfer anything here or no? What are we doing now? I know the truth value of a symbol.
The horseshoe in the fourth premise inside out, the parentheses.
Right here? What about that?
That's true.
Yes. Same reasoning. Antecedent is known to be false. Automatically makes the horseshoe true. And what can you tell me about that curl?
False.
No.
It has to be.
Wait, why does it?
What can you tell me about the truth value of that curl?
Has to be false.
No.
Well, it doesn't matter.
It doesn't matter what that curl is.
Doesn't, isn't the horseshoe not matter in that one? A horseshoe doesn't have to be true. It can be true or false.
Yeah, that's true, it doesn't matter. Why did we have a true there? We had a true there because we said B was transferred here. So, but we do know it's true. You're right, it doesn't matter, but we know it's true. And then the curl doesn't matter, and therefore, if the curl doesn't matter,
Then F does.
that doesn't matter. Woo. I know the truth value of one symbol.
Tri-bar.
The tribar must be
True.
okay. I think we're at an impasse. Well, not an impasse. Something like this might come up on the test. We've made some assumptions like, well, this doesn't matter, so I'll use a slash. That's good. That might be involved on the test, right? And those are necessary to continue the procedure. And now we have something that I don't think came up last week, but I'm pretty sure it came up the week before. We now have a situation where there are some symbols left, and we're not certain of their truth values. There are 3 ways this horseshoe could be true, right? How many ways are there that this tribar can be true? 2. So which avenue do you think we ought to take? The one where there's 2 possibilities or one where there's 3 possibilities?
The one
The one
with two.
where there's 2. It's the path of least resistance. So what do we want to do? This is all. No big deal. I mean, this isn't really even necessary what I'm doing here, but I just want to be real clear. Oops. Yeah. We only have to try 2 substitutions, right? We have to make F and G false there, true there, and then transfer those truth values. See what happens up here? Now, listen, if the assignment of true for both F and G, if that allows us to complete the procedure, okay, then it's invalid. You don't have to try false for both F and G, because we will have found at least one row, right, on which the premises are true and the conclusion false. But listen up. If assuming that F and G are both true, if that leads to a contradiction, you can't stop there. You have to try F false for both F and G. See? Because maybe there is a row where F and G are both false, but not one on which they're true, an invalidating row. So did you get that? Let's see what happens here. I'm going to go with true for F and G here. That'll certainly justify that true horseshoe. I'm going to transfer those truth values here. Right? That's going to make this curl false. The curl of G is going to be false. That horseshoe is going to be true. That's going to be a true horseshoe. So this row exists on the very long truth table. We don't have to try making F and G both false. Get it? But again, I'm going to repeat this. If putting true in for both F and G had led to a contradiction, there's still another possible row to be found. See? If T led us to a contradiction, that just means the invalidating row, if there is one, doesn't have G and F both true. Could be another row where they're both false. I hope I explained that well, because it's kind of a big deal.
If we find the invalidating row, we could stop.
Yes.
Prove it wrong, we're done.
Yes, this
If
is
we
when
don't
we're,
find the wrong one, we continue until we find the wrong one and it.
all
seems
possibilities.
impossible.
Yeah, you have to continue with the other possibilities. We would have had to try false for both F and G if we found a contradiction here. Yep,